Hello everyone. In this video, I'm going to explain the actual meaning of sine and cosine. Have you ever wondered about the meaning of sine and cosine when you were in school days? Let's go ahead and find out the actual meaning of those terms. In order for us to do that, we have to do a small exercise. Okay, take a compass and draw a unit circle, that is a circle of radius 1 centimeter, and divide it into 12 parts like this. There has to be a division every 30 degree until you reach the 360 degree. And then what you have to do is consider this point, the point where this 30-degree line meets the circle. You have to measure the y coordinate of that point, that is the y displacement from the origin of this point. That is like this distance will exactly be at 30 degree. The y displacement is 0.5 centimeter. If you take your scale as 0.5, I mean 1 centimeter. For 60 degree line, 0.87. For 90 degree line, it is very intuitive that it will be 1, because at 90 degree the circle inscribed is 1 centimeter. And similarly, for every 30 degree, you need to measure the y displacement, that is distance from origin in y direction, in positive as well as in negative y axis. And you will get a result like this. For until 360 degree, you would have documented the y displacement. Now you have to repeat the same process for x coordinate, that is x displacement for every 30 degree. And for 0 degree, you will know that the displacement would be 90 degrees, since this radius is 1. And if you document again for angle versus displacement, you will get the value like this. And this is the plot of angle versus y displacement. For every angle, you plot it and you get a curve like this. This is not so smooth, but in reality it will be a smooth curve. And this is the plot of angle and x displacement, that is x displacement is over here and angle is over here. And you will realize that this the name of this curve actually is sine curve, and the name of this curve is cosine curve. And from this, let's do another experiment. This is the both the plots drawn together. Let's do another exercise. If we draw a circle of radius 2 centimeter, and that is you are scaling the circle with the factor of 2, and you will realize that the value actually get multiplied, that is x coordinate gets multiplied by 2 and y coordinate gets multiplied by 2. And consider the radius as scaling factor, and if you divide x coordinate with the scaling factor, that is the radius of the circle, you will get the same value for the circle of any size. You can notice now that we have established a pattern over here, and we can use it to our advantage. The coordinate ratio tools holds true for circle of any size. It can also be used for studying triangles. Like, since we know that for angle of 30 degree, we know the x displacement ratio, that is x displacement by the radius will be a constant value, and y displacement by the radius will be a constant value too. That is, in case we inscribe a triangle inside this circle, we can use it to our advantage to study the triangles. And we call this radius into hypotenuse of the triangle. And this is x coordinate, that is adjacent side of this angle. This is opposite side of this angle. And y coordinate becomes opposite side, as you know. The opposite side by the scaling factor, that is the radius, in terms of triangle, that is hypotenuse, is a constant value at the particular angle. That is, opposite by hypotenuse is sine of that particular angle. And similarly, adjacent by hypotenuse is cosine of that particular angle. That is, the curve plays the major role here. And if we know any two of these variables, we can find out the other two variables. Suppose we know the angle and hypotenuse, we can go ahead and find out x coordinate, that is adjacent side and opposite side.